Okay, welcome geometry students. Here's our first geometry exam review. And for this particular review, I'm going to be concentrating on the algebra that comes in geometry. Obviously, we've all had Algebra 1. And if you noticed, each of the first 8 tests we've had a little bit of algebra. I've got the test over here on the left. And I just want to highlight some of these types of questions that you'll see on the exam. On the exam, we're going to start with 8 algebra problems. And all of these are going to be similar to the ones that I'm going to highlight on this video. Okay, so the first thing you have to be able to do in algebra is to combine like terms. So think about like terms. If you remember the last test we had, the transformations test, we had a couple of lines, L1 and L2. And we had a point that was reflected. It came over to here, and then that point was reflected across L2. And the test required you to write, the distance in here was A, and the distance in here was B. But because of the properties of reflection, we also had this distance was A, exactly the same, and this distance was exactly B. And then you had to, as part of the problem, you had to figure out how far it was from one point to its translation. And that's an example of adding like terms. So if you look at the A's, we had an A and another A, and then to that you had to add the lengths B and another B. So the answer to that was 2 A's and 2 B's, adding like terms. Okay, so look at the review question, adding like terms. Where might we see one like that? Oh, how about in chapter 2, this particular problem here where it says simplify. Okay, so if you look at that, chapter 2, simplify, we had 5x squared minus an x squared. So we're adding, actually subtracting like terms. 5x squares take away 1x squared, obviously 4x squares. Okay, so that's the way you would do that question. There's another add like terms in 3b, and we'll get to that in just a second. Okay, second exam question is going to be using the distributive property, right? The distributive property, and we saw some of those on our algebra tests. So if we looked at chapter 3 over here, go back to chapter 3, and that's a distributive property, and then there was some solving equations, and we're going to see both of those. But let's look at the distributive property where we had 9 times x minus 8, and you had to work that through, or 4x times 4 plus x. And if you remember the distributive property, you have to multiply these, so that gives you 9 times x. And then you had to multiply these. Don't forget the minus sign there. So 9 times a negative 8 is a negative 72. And that's the way you would do that one. And for the second example, again, using the distributive property, the first multiplication, we have 4x times 4. Keep your wits about you. 4 by 4 is 16, but there's still an x there, so 16x. And then in the second multiplication, we have 4x times a positive x, so still positive, 4, and then the x times the x, I suppose you could write as xx. That's not very exciting. Let's write it the way it's normally written, 16x, and then this would be 4x squares, right? 2 factors of x is x squared, and that's using the distributive property. Okay, our third exam algebra problem is going to be solving equations. And again, we saw some of those on the test. Let me clean this up over here on the left. And solving equations, we had a couple of them. These right here we had to solve. And you'll have to solve a simple equation on your exam. So let's look at the ones that you had to do during your tests. 3x plus 20 is 8. And we called this back in Algebra 1, a 2-step equation. The first thing you had to do was subtract off the 20, right? And some people actually like doing it this way. I think you could probably do this in your head. But we have 3x and 8 subtract 20 is minus 12. And then you had to divide both sides by 3. Again, whether you write down the divide by 3, I don't think is important. You would have 1x is equal to -4, and that was the solution. Okay. The second, let me scroll down here a little bit. The second equation that you had on your test over here required a little bit more work. Notice there was a 7 times x minus 4. That's a distributive property. We're going to have to deal with that first. And on the right side, we had 5x plus 2. So work the distributive property first. 7 times x is 7x, and I'll write it underneath here, 7x. And then 7 times the -4, be careful with the negative sign, and we would have -28. And the right side of the equation is already simplified, 5x plus 2. Okay, for an equation of this type, you now had to move all the x's to one side. Most people would just go ahead and write minus 5x, right? Both sides, whatever you do to one side, you have to do to the other. So 7x take away 5x is 2x's. We still have the minus 28. And on the right side, 5x take away 5x is no x's, but we still have the 2. Okay, so now we're back to our two-step equation like at the beginning. And I'll do this one a little bit more quickly. I'll just add 28 to both sides. So I have 2x is equal to 30. And then I'll divide both sides by the 2. So I'll have x is equal to 15. Remember, in all equations, you could always check, if you had some spare time, try putting x is equal to 15 all the way back up into the original equation. And if it came out to be a true statement, then you have the correct answer. Okay, let's see. The fourth exam question is going to be a simplify type of problem, and these could be subtract or add, and generally, again, like terms. So if you look at the test back in chapter 2, again, we had some simplify types. We've already seen the first one where we had 5x squared minus x squared, but let's look at the second one, 6x minus y, and from that you had to subtract the x minus 7y. A lot of students get confused here. There really is a 1 in front of the second set of parentheses. So before we do any of the simplifying or the adding like terms, we do have to do a little bit of distributing. So 6x minus y, nothing happens there. But here's where we have to be a little careful. We have this minus 1. We have to multiply it here. That's minus 1x. And we also have to multiply it against the negative 7y. So negative times a negative is a positive 7y. And after you've done that, then you can go ahead and add up like terms. For the x's, we've got 6x, take away an x, that's 5x's. And on the y's, we've got 1y and 7y's are 6y's. And that would be the simplified version of that algebra problem. Okay, let me pause it here. Okay, we're back again. And let's look at problem number 5, which is going to be a factoring problem. So you had to do some factoring on the test. If we look at the test, there was factoring back in chapter 5. And so some factorings. Now, what types? Well, trinomials are ones that you're going to see. A trinomial like this 1b, where we had x squared plus 8x plus 15, x squared plus 8x plus 15. The way you break that up, a couple sets of parentheses, x and x, those two will multiply together to give you the x squared. Both of these are positive, so we have some positives here. And we need to think of the factors of 15, 3, and 5 come to mind. And then whenever you do a factoring problem, you should always check. So there's your x squared. I'm doing the foiling here. There's our 5x's and 3x's and 15. Okay. So sure enough, x squared plus 8x's plus 15. So those aren't too bad. Now, if you have a trinomial where the leading coefficient's not 1, things get a little bit more interesting. But you had one of those on your test. That was this one here, 5x squared plus 6x minus 8. 5x squared plus 6x minus 8. And again, the idea is to break it up, a couple sets of parentheses. To get the 5x squared, we need a 5x and an x. And now for the 8, a little bit of trial and error. You know, 8 could be 1 and 8. It could be 2 and 4, 4 and 2, 8 and 1. Obviously, the negative sign means we need to have a negative in here somewhere. So let's try a negative there and a positive there. And then there are methods for doing this, but let's just do a trial and error because many students succeed with that. So if we put a 1 and an 8 here, just to see that's our first pair, we're checking the middle term. That's what we're looking for. So work with your outsides. Oh, well, that's 40 x's. That looks way too much. The inside, we only have minus 1x. So that's not going to give us our 6x. Remember, we need 6x. So that's wrong. Let's back those out and try another pair. Instead of 1, 8, let's try 2, 4. Okay, so we'll try a 2, 4 because that's the second pair that could fit in there. And again, we'll go ahead and we know the first work. There's your 5x squared. We know the last work. So that's the negative 2 times 4 is negative 8. So that's okay. We just have to check this middle term. So let's see. The outer 5x times 4 is 20x. Again, pretty large. That's probably not going to work. Okay, minus 2. No, not there. Although we are getting closer. Let's try swapping these around. Again, this trial and error method isn't the most efficient, but it will get you to the answer eventually. The next pair we could try is 4, 2, 4, 2. And now this does look promising. And if you just tried it yourself, you'd see this would work. Your outer ones, there's your 10x's, and then minus 4x's. And sure enough, that's going to be our 6x's. Okay, so this is the way this one factored on the test. And if you wanted to double check, you could just FOIL it out and you would see that you would get 5x squared plus 6x minus 8. Now, the last type of factoring that's really, really common is difference of squares. You had to deal with x squared minus 9y squared. That was on your test. Let's see, where was that? That was here. And most students are pretty happy with difference of squares immediately. Set of parentheses, x minus x plus. And to get the 9y squared, 3y and 3y. And then just FOIL it out to double check. There's x squares, there's plus 3xy's, but the middle term gives us a minus 3xy, and the last term is minus 9y squared. So sure enough, these go away, and you end up with x squared minus 9y squared. Okay, most students like difference of squares. Okay, next exam question is going to be one on reducing fractions. It's interesting, a reduced fraction is really a factor problem in disguise. So if you can factor, then you can reduce. Reducing fractions on your tests, let's see, chapter 6, we had to reduce some fractions. So chapter 6, you had to reduce, well, let's go to B. So we had 5x minus 5 over 10x minus 10. And like I say, it's really factor. So factor the top. The only thing that comes out is the 5, the common factor of 5, x minus 1. And on the bottom, we have a common factor of 10, x minus 1. Again, whenever you factor, you could check to make sure you did it right. There's 5x minus 5 using distributive, and 10x minus 10. Okay, so those are good. But now, once you've factored, cancel the common factors. And on the test, that's what you needed to do. This was 5 over 10 or 1 over 2. Okay, let's suppose it was a little bit more interesting. Suppose we had, go back to our difference of squares. Suppose we had x plus 3y over x squared minus 9y squared. So this is picking up on this difference of squares. Again, this really is a factoring problem in disguise. So the first thing we have to do is try to factor. Well, the top doesn't factor. There's nothing you can do with x plus 3y, so that stays by itself. But the bottom, the difference of squares, we already saw how that factored. X minus 3y and x plus 3y. There's our difference of squares. And then, lo and behold, we do have some common factors. So this entire numerator will cancel with this entire factor down here, x plus 3y. And what we're left with on top, we just have a factor of 1. So 1. And on the bottom, we have x minus 3y. And that can't be reduced, so that's our final answer. Okay. Let's see. Single fraction in lowest terms. So let's see, lowest terms. So this was one that we had to write as a single fraction. And I'll play with this one as well to sort of give you a clue as to what you're going to be working on your exam. Okay, so the first one, this is a write as a single fraction in lowest terms. Okay, typical exam problem. Let's see. On the test, you had x over 2 plus x over 5. And if you remember fractions back in Algebra 1, you can do this as long as you had a common denominator. So you looked at the 2 and you looked at the 5 and said, I know the common denominator is 10. And there's lots of ways of doing this again, but most students think, let's see, 2 goes into 10 5 times, so 5 times x is 5x, and 5 goes into 10 2 times, and 2 times x is 2x, and then we can add these up. So common denominator, 5x and 2x is 7x, and that's the way you did the test question. Fractions can get a lot more interesting than that. One of the test questions was a multiplication problem. We had x plus 6 over 4, and you were supposed to multiply that times 2 over 3, Well, let's pretend instead of a multiply, this was a subtraction problem. Aha. Okay, so once again, in order to add or subtract, you have to get a common denominator. And most students would look at this and go, I know the common denominator between the 4 and the 3 is 12. So the task now is to figure out how we modify the tops. And very similar to what we did up above, we think, okay, 4 goes into 12 3 times. So I have to multiply this one by 3. Let's see, that would be 3x. Now be careful. You also have to multiply times the 6, 3x plus 18. Aha, that's the first numerator. And for the second one, let's see, 3 goes into 12 4 times, and 4 times 2 is 8. Okay, so now we can go ahead and subtract. I'll scroll down here just a little bit. We have 3x plus 18 over 12, and we're subtracting the 8 over the 12. Common denominator is 12, and so we have 3x plus 18 minus 8, and then just the like terms, the constants there, 3x take away, or let's see, add 10, right? 18 minus 8 is 10, still over 12. And that would be it. Nothing reduces. There's no common factors. That would be the answer to that problem. And the last exam problem is going to be a radical, last exam algebra problem, that is. It's going to be a radical in lowest terms. And we saw these, a lot of times we see these in distance problems. Your test, you had to write square root of 44, and on the solution you saw that was square root of 4 times 11. You're trying to find that perfect square in 44. And then you think that's the square root of 4, which I know, square root of 11 is irrational. So 2 square roots of 11. And that was it. Later on the test, you had to simplify a radical that involved the square root of 75. So again, thinking on how you would do that, looking for the perfect square in 75, you might recognize 25. 25 times 3 is 75. So we have the square root of 25 times the square root of 3, and we know the square root of 25. That's just the number 5, and the square root of 3 is irrational. So we're done. You'll see one like this on the exam. I don't want to give you the exact problem, but let's suppose we had the square root of 48. Okay, so we're looking for a perfect square in 48. And you might be able to see, and remember the perfect squares are 4. 4 does go into 48. You could write this as 4 times 12. Okay, so that would work. 4 times 12. And the square root of 4 is 2. Square root of 12 But you're not done because, the square root of 12 can be broken up. Well, let's see, square root of 12, I see another 4 in there. 4 times 3, so square root of 4 times the square root of 3, which is 2 square roots of 3, and that's the square root of 12. So it looks like if we did it this way, we'd have the 2 originally, plus the square root of 12 turned into this, so 2 times the square root of 3, or 4 square roots of 3. Now, if you were just a little bit more astute, you might be able to see, 48 is 16 times 3. 16 times 3 is 48. So square root of 16, square root of 3, and we know the square root of 3 is 4. And the square root of 16 is 4, and the square root of 3 is irrational. So there's our answer. Same way we did it the other way, but a little bit more efficient. Okay. Work those 8 problems again and again until you feel comfortable with them. I expect to see the first 8 exam questions as algebra. Algebra. Right? Okay, that'll be the end of this little review video. I'll put some more up over the next day or so.